Okay, students, let's move on to our next topic, type of chemical reactions. We have 5 different type of chemical reactions. You can see in this flow chart, we've classified the reactions in 5 different categories. It's a combination reaction, it's a decomposition reaction, it's a displacement reaction, double displacement reaction, and redox reactions. We can further classify some of these reactions into different types. Say this decomposition reaction can be further classified as a thermal decomposition, electrolytic decomposition, photo decomposition. The basis of this decomposition is the energy supplied. We'll discuss more about this after a short while. Displacement reaction. Double displacement reaction we can further classify as a neutralization and precipitation, and redox reaction can further be classified as oxidation and reduction. Now let's understand, student, what is combination reaction. Combination, as the name itself says, when two or more substances combines to give one single product, we say it's a combination reaction. Here you can see this example, C plus O2 gives us CO2. You can see two reactant combines to give us one single product. Calcium oxide plus water combines to give us calcium hydroxide. Two reactant combines to give one single product. So this is the example of a combination reaction. Combination. When two or more substances combines to give us one single product, we say it's a combination reaction. Now decomposition. Decomposition reactions. This is just the opposite of a combination reaction. As the name itself says decomposition, that means in this reaction, a single substance will be decomposed, will be broken down into two or more new substances. Now to break down any substance, we need the energy. We need to supply the energy. Now, the energy may be supplied in any one of the three forms. We may supply the energy in the form of a heat. If we supply the energy in the form of a heat, the reaction type is called thermal decomposition. Thermal means heat. So energy supplied in the form of a heat, it's a thermal decomposition. If we supply the energy in the form of electricity, we'll call such decomposition reaction as the electrolytic decomposition. And if the energy is supplied in the form of a light, we can say such reactions as a photo decomposition reactions. So this classification is based on the type of energy being supplied. If we are supplying the energy in the form of a heat, we'll call such decomposition reaction as a thermal decomposition. If energy is supplied in the form of a light or electricity, we may say such decomposition as an electrolytic decomposition. And if energy is supplied in the form of a heat or light, we say such decomposition reaction as a photo decomposition reactions. Now third type of reactions. Before we move on to third type of reactions, let's understand this electrolytic decomposition examples. Here we have calcium carbonate, a single substance decomposes to give you calcium oxide and carbon dioxide. Two new substances formed. But for this decomposition to occur, we need to supply the energy in the form of a heat. So this is the example of thermal decomposition reaction. We have another example. Water. If you want to decompose water into hydrogen and oxygen, so you have to supply the energy in the form of electricity. So here energy is supplied in the form of electricity. So this is an example of electrolytic decomposition. Now we have AgCl, silver chloride, broken down to silver and chlorine. Now to break this silver chloride into silver and chlorine, we have supplied the energy in the form of a light. So this is the example of a photo decomposition reactions. So this is the type of electrolytic decomposition. Decomposition reactions. Now let's move on to displacement reactions. Displacement reactions, it's a type of reactions where a highly reactive metal displaces a less reactive metal from its salt solution. Displacement. We can see two examples here. Let's understand these two reactions are possible or not. If these two reactions are possible, why they are possible? If they are not possible, why they are not possible? Let's understand this. Zinc plus HCl, ZnCl2 plus H2, Cu plus HCl, Cu2 plus H2. So if I ask which one of the two reactions is possible, so we'll say this reaction is possible, but this reaction is not possible. So why this is so? Now to understand whether displacement reaction will occur or not, we must understand the reactivity series. We must understand the reactivity series. Reactivity series, page number 45, table 3.2. Our NCERT textbook, page number 45, table number 3.2, we have a reactivity series. If you go through this reactivity series and if you compare the reactivity of a zinc, hydrogen and copper, you will see this order. Zinc is kept above in the reactivity series, it means zinc is highly reactive. And copper is in the bottom of the reactivity series, it means copper is less reactive. And hydrogen is in between zinc and copper. It means hydrogen is less reactive than zinc, but hydrogen is more reactive than copper. So here you see zinc being more reactive than hydrogen, zinc is able to displace hydrogen. So this is the displacement reaction. So zinc has displaced hydrogen. Copper plus HCl. Copper, if you compare the reactivity series, copper is below hydrogen in the reactivity series, means copper is less reactive than hydrogen. So copper is not able to displace the reaction, displace this hydrogen. So that's why this reaction is not possible. So this is how we can compare the displacement reaction. I hope you understood what is displacement reactions and how to identify a given reaction is displacement or not, or a displacement reaction will occur or not. Okay, now let's move on to another type of reaction. It's a double displacement reactions. We can further classify this double displacement reaction as a neutralization and precipitations. Let's see what is the basis of classifying this double displacement reaction, and let's understand what is double displacement reaction. Remember one thing, for the double displacement reaction to occur, we need a reactant in their aqueous form. That means our reactant should be aqueous solutions. So when we mix the aqueous solutions, there will be exchange of ions. In this sodium sulfate, we have two ions. It's a sodium ion and sulfate ion. We have a barium ion and chloride ion. So sodium ion, sulfate ions together, barium ions, chloride ions together. After the reaction, you can see sodium ions and chloride ions goes together. Barium ions and sulfate ions combines together. So there is exchange of ions. So during double decomposition reactions, if you mix two aqueous solutions, there will be exchange of ions and the product is formed. Now, on the basis of the product formed, what type of product is formed? We classified this double displacement reaction as a neutralization and precipitation. If the product formed is solid insoluble substance, PPT, you can see during this reaction, a solid substance has formed. It's a PPT. That means precipitate is formed in this reaction. In this double displacement reaction, precipitate is formed. So that's why this double displacement reaction is given in name precipitation reaction. This is the example of a precipitation reaction. Now we have another example. This is also aqueous solution. If we combine these two aqueous solutions, our new product formed is NaCl, which also dissolves in water. So in this reactions, none of the two product form is precipitate. So this reaction we can classify as a neutralization reaction. This reaction is also a neutralization reaction. Why? Because we have base and acids, and we all know base and acids neutralizes each other to form salt and water. So this is a neutralization reaction. So both these reactions are type of double displacement reactions. So remember, in double displacement reactions, there will be exchange of ions, and the product formed may be a precipitate, may not be a precipitate. So during the double displacement reaction, if product formed is precipitate, we say such reaction is a precipitation reaction. If the product form is not a precipitate, then we say such reaction as neutralization reactions. So that's all about this double displacement reactions. Now we have the final reaction. It's a redox reactions. Now redox reaction is actually reduction and oxidation. If you observe, this word redox is composed of a two word, reduction and oxidation. So in short, redox. So let's understand what is oxidation and reduction. So here is a simple definition, a trick to remember this reaction. Oxidation and reduction. You can see we have a two way of defining oxidation and two different way of defining reduction. So addition of oxygen and removal of hydrogen is called oxidation. That's one way of defining oxidation reaction. Removal of NM. Here NM stands for a non-metal. NM stands for non-metal and M stands for metal. Removal of non-metal, addition of non-metal and removal of metal. Addition of non-metal and removal of non-metal is called oxidation. Removal of oxygen, addition of hydrogen is a reduction. That's one way of defining reduction. Removal of non-metal and addition of metal. Addition of metal, that's another way of defining reduction. So addition of oxygen, removal of hydrogen, that's oxidation. Addition of non-metal, removal of metal, it's oxidation again. Removal of oxidation, removal of oxygen, addition of hydrogen, it's a reduction. Removal of non-metal, addition of metal, it's a reduction. So that's how we can define oxidation and reduction process. Here is an example to illustrate this definitions. Copper oxide plus H2 gives copper plus hydrogen. If you see the reactant copper oxide and see the product copper, initially we start with copper oxide and we end up getting copper. It means from copper oxide, oxygen is removed. So now from the definition, removal of oxygen is called reduction. So this process, copper oxide to copper, is a reduction process. Now we have a hydrogen initially, and at the end we have water. To hydrogen, oxygen is added. To hydrogen, oxygen is added. So by definition, oxygen addition of oxygen is called oxidation. So from hydrogen to water, it's oxidation process. So in this reaction, the substance from where oxygen is lost is said to be reduced. The substance from where oxygen is lost is said to be reduced. And the substance where oxygen is added, the substance is said to be oxidized. So substance from where oxygen is lost, it's reduced, and the substance to which oxygen is added, it's oxidized. So we have oxidized substance as a hydrogen, substance reduced as a copper oxide. So substance oxidized will be a reducing agent. Substance oxidized will be reducing agent, and substance reduced will be oxidizing agent. So oxidized substance is hydrogen, so our reducing agent is hydrogen. Substance reduced is copper oxide, our oxidizing agent is copper oxide. So I hope, student, you understood the type of chemical reactions. Chemical reactions and equation chapter is finished.